Implicit differentiation. We already know how to differentiate a function in the form y equals f of x. But how would we differentiate a function in the form c equals f of xy? So a function in terms of both x and y equaling a constant. So if we have a combination of two functions, so g of x plus another function h of y is equal to c. So we've got two functions here, one in x and one in y. Now, generally, we have form y equals f of x, and so if we change this one around and call y a function of x, then it makes it possible to solve. So now we have g of x plus h, and then y is also going to be a function of x, and that's going to be equal to c. So now we can differentiate this. If we want to differentiate g of x, that's just a function of x, we can differentiate that as g of x. Then we're going to leave this bit for a second. So we can leave it as the derivative of h of y of x, and then the constant just goes to 0. Now, having a look at this term here in the middle, work over on the right hand side here, we can see that we have a function of a function. So if we want to differentiate a function of the function, we use the chain rule. So if we let u equals y of x, du by dx is equal to y prime of x, because it's just a function of x, and then d over dx of h of u, which is equal to the derivative of h in terms of u, which is h prime u, and this is with respect to u, times by y prime of x, du by dx. Okay, so we can just make this a bit clearer and go, this bit is dh by du, and then this bit is du by dx. So going back to differentiating g of x plus h of y, we've got g prime of x, that's prime, plus, and this is h prime of y of x, times by y prime of x. Now we can write y prime of x as dy by dx. And then if we wanted to solve to find out what dy by dx is, then we would make dy by dx the subject. So take away g prime of x, that equals negative g prime of x, and then we would divide by h prime of y, and we can lose the fact that y is a function of x because we're not bothered about that anymore. G prime of x over h prime of y. Ooh, got a bit messy. H prime of y, and that is the general form of implicit differentiation. So now we're going to have a look at an example. So we want to find the slope of the circle x squared plus y squared equals 4 at the point negative root 2, root 2. So first thing we're going to do is we've got our function and we're going to differentiate it with respect to x. So the derivative of x squared plus the don't know why I was doing that. Derivative of y squared is equal to the derivative of 4. Then we know obviously how to differentiate x squared, which is 2x, normal explicit differentiation. Then we can differentiate y squared with respect to x, so it gives us 2y, which is the derivative of h of x with respect to u, as before, and then we're going to times that by dy by dx. That's going to be equal to 0 because the derivative with respect to x of constant is 0. Then we can just rearrange to make dy by dx the subject, and that comes to, in a bad mood today, 2x over 2y, negative, and that is negative x over y is our gradient. Now what we're going to do is we're going to put in the initial values to find the slope at that point, which is minus root 2 root 2. So dy by dx is equal to negative root 2 over root 2. The negatives cancel as do the root 2's, so that just gives us 1. And that is our answer. This has been implicit differentiation. Thank you.